let me tell you a little bit about myself, and then I'll tell you about what we're gonna do today. So basically, my name is Marko, and I've been doing a lot of Android training for the past couple of years. Before I started doing Android training, I was doing Java since before it was really Java, since about 94, 95, when it was a little project at Sun back in the day. And back then I was really interested in embedded systems. That's why I kind of got interested in Java in the first place. But as we know, Java sort of took off more as the platform for web apps and enterprise applications rather than embedded software. So that's what I was doing for the past decade and a half or so. Until Android came out. So for the past couple of years, I've been extensively doing Android, mostly Android training, going around the world, doing classes for companies such as Qualcomm, Motorola, Department of Defense, and so on and so on. And I'm also author of a book called Learning Android that's coming out this month by O'Reilly. So look out for that. And I frequently speak at conferences such as OSCON, IEEE, ACM, and now AnDevCon. So that's a little bit about my background. I also started an organization called San Francisco Android Users Group. It's a San Francisco-based Android users group, and we put together a lot of great learning events in the evenings once a month. So with that, let me tell you a little bit about what we are going to do today. So we're going to talk a little bit about the stack. It sounds like some of you may know some of these things here, so we may fast forward through that. We're going to do a hello world. The purpose of this is going to be A, to test that you guys have your environment set up, if anybody has any questions about the environment. But B, I'm also going to go a little into the details of the application, sort of dissect it, right? So sort of like open it up and point out what is what and how it all kind of gets put together into an application. And then we're going to talk about a topic that I consider important, and that's the main building blocks, or Android components. These are things that are sort of very specific to Android. These are sort of Android constructs, and are new to a lot of Java developers. So we're going to talk about that, but we're going to talk about that in a context of an actual application. So once we do that, we're going to look at what it takes to design an application. So this is going to be lines and circles sort of a conversation. So it's going to be very much about the architecture of an application, more so than just coding it. And then we're going to talk about UI a little bit, because I find that that's usually an area that a lot of people have issues with. And then we're going to talk a little bit about some operating system features, some debugging tools, and so on. But keep in mind that this is not so scripted, this presentation. So if you guys have questions, if you want to kind of drive it in a certain direction, if you want to move it faster, slower, it's really up to you. So I'll be asking you for for any questions and any feedback as we keep on going, so we can adjust as we go through the day. So with that, let's start with the stack. So I just want to kind of give you a high-level overview of what Android operating system is. And how many of you have seen this picture or similar picture? A couple of you. All right, so we're just going to look at the very big picture of Android. We're going to sort of start looking at from the bottom up and kind of understanding what is what. So the very bottom of everything is Linux. As you know, Android is built on top of Linux kernel. So we borrowed Linux kernel and we laid out many layers on top of it. The reasons for Linux are multifold. One of the main reasons is that it's really easy to port it to many different platforms. So that was the goal of Android project right from the get-go, right? It wasn't about a single phone, a single gizmo. It was more about being able to run on many different platforms. And that sort of business decision trickles down into a lot of technical decisions later on. So many different platforms, right? And Linux is fairly portable, so it makes it fairly easy to do that. Provides that abstraction layer. There are certain other things that Linux provides, such as memory management, user management, power management, networking, radio, etc. So those are very low-level things. As app developers, we typically don't care about this too much. As platform developers, we do, but that's a different story. So on top of Linux, we basically have a whole bunch of native libraries. And the native libraries are things that are more or less copy-paste from other open source projects. So these are things that were needed to complete the big picture, right? So for example, we needed a database, so we got SQLite database. We needed a way to render HTML, so we borrowed the WebKit library and plugged it into the Android OS. We needed OpenSSL, OpenGL, things of that nature, right? So these are C++ libraries that are there to make the whole stack complete, right? Bionic is a minor exception, which is basically a rewrite of standard libc library, and one of the reasons for that is the license. So keep in mind that the goal of the Android project is to make it easy for developers to make changes in any part of the system and keep those changes, right? So most of the stack is basically licensed under MIT Apache license. So that's one of the reasons why Bionic is a different version of libc. So going forward with that, the next thing that we have sort of in that stack is Dalvik. Dalvik is basically a replacement virtual machine that replaces Java virtual machine. So all you guys are Java developers, you know what I'm talking about. So there's no Java virtual machine basically in Android. All your code, all your Java code is going to run on Dalvik VM. So why develop Dalvik in the first place? Why not go with Java? There are a couple of reasons for that. One is sort of there's a couple of business reasons, there are a couple of technical reasons. From technical standpoint, Java virtual machine was one-size-fits-all VM that runs Java on anything from a tiny little phone to a supercomputer, right? So as such, you can only optimize it to a certain degree, right? Because you gotta sort of have the same VM across the board. So the Android team felt that they can do a much better job optimizing the virtual machine, and that's the technical reason for Dalvik. So Dalvik is highly optimized for small devices. What that means is technically it's registry based as opposed to stack based, because a lot of these small devices are based on registers as opposed to having a lot of memory to run stack based applications. So that's from a technical standpoint. From business standpoint, it's the license issue, right? So Dalvik is open source as an Apache license, which means you don't have to deal with Oracle or anything like that in terms of licensing Java. Dalvik is pretty fast as well. It comes with a just-in-time compiler and so forth. Any ideas why I put this picture here? Looks nice? Yes. Yes, Dalvik is the name of a fisherman village in Iceland. That's what it looks like. It's got a church and that's about it. So yeah. Cool. So that's Dalvik. We'll talk a little bit more about Dalvik and how it relates to Java once we talk about Java. So that's coming up. So we'll double click on that just so you know. On top of that, we have the app framework. So this is the layer that is very rich in functionality. It's very well documented, and this is the part of the stack that you guys as application developers interact with, right? So this is where we program against it when we write applications. Application framework provides all those nice features, such as figuring out what your location is, playing various media types, connecting to internet, etc., etc. So anything that you want to do from application standpoint is provided to you here in a nice packaged way. So beyond application framework, we basically have applications. So lots of different applications. Let's take a look at roughly what an application is. So an application, at the end of the day, is going to be a single file. It's going to be an APK file, application package, right? It's essentially a zip file. And what it consists of is essentially your Java code that's now made into a Dalvik executable, right? So you're going to have some compiled Java code. And it also consists of resources. So resources are things that are not code. Okay, so what would be the things that you have in your application that are not code? Images, constants, sound clips, layouts, all the text, all your English, right? All that stuff is not code. So Android application development sort of forces you to think in terms of separating those two concerns, right? So having code be just the business logic, and then having everything else be outside of the code base, right? So we're separating those two. That's an important thing. We'll talk about this more as we keep on going. Now, another thing, optional thing here that I put in is native libraries. We're not going to talk about that in this presentation. I'll talk a little bit more about that tomorrow. But you can basically have some C++ code as part of your application as well. Sometimes the performance is the reason for that. So that's essentially what an application is. It's usually these two things: your Dalvik executable and your resources. And I'll show you this, deeper in how this actually plays out on a file system as well as we keep on going. This is very high level at this point. A couple other things that I wanted to point out in terms of applications that you guys probably already know. Applications must be signed. So you got to sign your application before you distribute it, but you can self-sign it. You're basically self-signing it. You can either self-sign it with your private key, if you have one, or you can create one, or we typically sign it with the debug key when we're just in the development mode. Okay, so we're not going to be seeing the actual process of signing because it just happens magically behind the scenes using the debug key. But I just wanted to let you know that the applications are typically signed, and they must be signed before they're distributed. And as you know, that there are many different markets, unlike some other ecosystems such as iPhone and such. There are many different markets, Google being probably the biggest and best known one, but it's not the only one at all. So that's just a little bit about the applications. Any questions on the stack so far? Is there any trouble of interfacing Dalvik code with Java code, right? The existing Java code, right? Yeah. So the answer is going to be on the next slide, but essentially you're not going to have the Java code. Java code is going to get compiled to Dalvik as well. So it's going to be really Dalvik interfacing with Dalvik. So, but let's double click on that on the next slide. So I'll show you how that actually works. Any other questions on this? Yeah. Any comparison done between Dalvik and Java in terms of performance? Virtual machine to virtual machine. I don't really know. I'm not sure of that. So I know that basically one of the things that we didn't have for a long time is just-in-time compiler, which basically makes the Java code run much faster because you're not interpreting it. And we got it finally with Froyo. And there are a couple of reasons why they felt it's okay to wait that long. One of the reasons is most of the so with just-in-time compiler you get speed boost when the application is actually running, but a lot of mobile apps are not really running. They're just sitting there, waiting for user input. So they're very much idle, right? So as such, having a much faster implementation is not going to show you, give you a lot of noticeable difference, right? So that's one of the reasons for that. Now, Dalvik's when they designed Dalvik, back to this, they looked at the constraints that we're dealing with in a mobile environment specifically, right? So they looked at mobile and they said, okay, what are the things that are not going to change for any time soon? How is mobile different than anything else, right? How is it different than your connected PC that you have on your desks, right? The battery is the biggest difference, right? So the battery is something that's going to be a constraint for a very long time, right? We're seeing an evolution in batteries, but we're not predicting any revolution in batteries anytime soon. So a lot of things that went into optimizing Dalvik have to do with battery performance and also the memory consumption, because what happens is the device itself is very small, so the amount of memory that we have available to us is always going to be limited by its sheer size, right? So there's some very smart things that Dalvik does in terms of using less memory. I'm going to talk about that next as well. Yeah. Any other questions? Yeah. What are the implications for the app developers for registry-based versus stack-based VMs? So all this stuff about what happens underneath the hood with Dalvik and all that, it's just interesting. But as an app developer, you pretty much don't care about all that. It just happens. It's just magic, right? So that's basically that. Now, in my experience, I ran some tests that are recursive, and that's something that typically requires a lot of stack, and that's why I see Dalvik take a huge performance hit. But I've been comparing Dalvik recursive code to C recursive code, and the difference is order of magnitude, so about 10 to 20 times. Depends on a test. So, but for the most part, as an app developer, you don't really care that it's running on Dalvik. Yeah, it just all that stuff happens behind the scenes. Any other questions on this? All right, so let me, since you guys are so interested in that, so let's move on to how Java and Android are different. Java and Dalvik are different. So let me start with this comparison here. So as you guys know, in standard Java, you write Java code, right? This is your .java file. You compile that file using JavaC compiler, and you get Java class file, right? .class file. That's your binary code. And that what we do next is then we put that Java bytecode on top of the Java virtual machine, right? So this is where it executes. It's the JVM running our .class file, essentially. So this is how standard Java works. This is how Dalvik works. We still write the very same Java source code, right? It's the very same Java source code. We still use the very same Java compiler, JavaC. We get the very same bytecode. This is still the .class file. Now, what's different is we take that bytecode and we compile it once again, right? So we use DX or DEX compiler to recompile that .class file and get a Dalvik bytecode, .dx file, right? And then we take that Dalvik bytecode and we execute it on top of the Dalvik virtual machine, right? So these steps are different. Does it make sense? So, so couple of things that are interesting here. Couple of things that are interesting here is that, for example, one question that I usually ask people is, why didn't they just go and do this? Why not just go from Java source code straight to Dalvik bytecode? Why create this intermediary step and then toss that away? Yeah. Exactly. You may have some Java libraries that you don't have a source code for, so you just want to bring them in. So that's back to the question about interfacing with existing Java code, right? So you would basically just take existing Java code and recompile it using Dalvik, right? So that's a good reason to base it on the bytecode. Another good reason is that Java compiler actually does useful stuff. So there's no real reason to reinvent the wheel, right? So that's why we start where JavaC left off, right? So that's another good reason for this. And another good reason that I like about this is that a lot of other languages also compile down to Java bytecode. So what that means is that you do not need Java to write Android apps, right? You can use Ruby, for example, and with JRuby, or Python with JPython, right? There's, I think, a presentation specifically on Ruby and writing Android apps using Ruby. So this is how it would work. You would just basically compile it down to Java bytecode, and everything else happens the same way with Java, right? So those are all the good reasons why it is architected the way it is. Pragmatically, the reason why they based Dalvik on the bytecode is because when they started working on Dalvik in 2005, Java was going through the major language change, right? That's when Java 5 came out. So that's why they felt that they didn't want to base the compiler on something that's in flux. So they based it on the class file, which was more of a set in stone standard at the time. So that's a little bit about how that works. Any questions on this part of the picture? Yeah. Is it possible to precompile Java libraries and link them in?
Yes, there's Dalvik libraries.
So basically Dalvik loads the libraries the same way Java loads the libraries, right? So you would need to have that class file compiled in the .dx file at some point. So you would need a Dalvik executable somewhere. How you get it is not important, but it's dynamically linked, right? Just like in Java. So it's not like linked into statically. Does that kind of answer it? So at the end of the day, you're going to have a zip file with your Dalvik version of binary code, as opposed to jar file with Java version of binary code. So, yeah. Any other questions on that? Okay, so with respect to, so that's how Dalvik works. Now, it may sound like this is a lot of extra work, but all these steps basically happen automatically by tools, right? So we don't really need to worry about any of this. This is just FYI. Now, a couple of other things that I wanted to point out. As you guys know, Java ships in a couple of packages, right? Java Standard Edition, Java Enterprise Edition, Java Mobile Edition, right? So Android's subset of Java libraries is essentially Java Standard Edition, right? So that's the starting point. We started with Java Standard Edition. But one of the big differences is that anything that has to do with the UI, namely AWT and Swing libraries, are gone, right? So this is sort of a big departure between Android Java and standard Java. So the UI libraries are totally different. The principles are very similar, but the libraries themselves are different, right? So we're gonna see this later on. But more or less everything else is there, right? So when it comes to networking, file I/O, any of that sort of stuff, that's basically the same as in standard Java, right? So that's just that's good to know because you don't need to worry about any of that. So that, and on top of that, we add some specific Android APIs. So that's how Android's Java is different than regular Java. Any questions on that? Everyone got it? Cool. So with that, we're gonna now talk a little bit about the little Hello World program and see how things work behind the scenes. Before we do that, how many of you, does everyone have environment setup, or does anybody need any help with have any questions about the environment setup? How many of you have SDK and Eclipse installed? All right, pretty much everyone. Cool. All right, so then let me just run through this really quick. So what I'm going to start my Eclipse in the meantime, but what I just wanted to point out is a couple of things. So so SDK. So as you guys know, when you download the SDK, you're basically just getting a shell into which you need to plug in various platforms, various add-ons. So add-ons and platforms, they go into their respective directories, right? Those are essentially the versions of Android that we're using. And then you also need to make sure that your tools and platform tools, these two directories, are part of your path, right? And then you're set, pretty much. And so in the meantime, I'm starting my Eclipse. Actually, I don't want to start this one. Helios is not as good as Galileo, so I'm going to quit this and restart it. It just uses way more memory for some reason. Okay. Cool. So what we're gonna do, what I'm gonna do right now is I'm gonna do a little, just create a little Hello World application. So file, new Android project. I'm assuming that you guys have your environment set up and all that, and most of you have done this. So I don't really expect you to follow Hello World by doing it, but I just wanted to talk a little bit about what happens and how things work and what the anatomy of an application is before we get into anything more complex. So project name, again, it's an Eclipse construct, so hello world. Just going to zoom in so you can see in the back. I think that's the other version of Eclipse. They just, that's the 3.6, so don't worry about that. As you guys know, Eclipse is fairly flimsy sometimes, buggy and so on, but the price is right, so can't really complain. All right, so these are the various targets, right? These are the various possible targets that I have installed on my laptop and in my SDK. So that's essentially saying what you're targeting with your application. So you typically want to target, the lower the better, because you have the wider audience for your application, right? But you can also say something like this. For example, I'm going to target 2.2 Android. So this is the open source version of Android 2.2. So I'm not expecting any bells and whistles on the actual phone, right? But later on, what I can do is I can specify what the minimum requirement for an application is, right? So that's we're going to see that in a second. So I'm targeting 2.2. Application name is just a arbitrary name. So hello, comma, space, and AnDevCon, exclamation marks. Now, package name is important. This is your standard Java package name, right? And the reason why it's important is because a lot of things are later on keyed off of this package name, right? So security is based on the package name. Signatures are based on a package name. File system is determined on based on a package name. So that's why the Java package name itself is fairly important. And it adheres to the standard Java name package name conventions, right? So com example, for example, hello, right? So that would be my package. Now, optionally, it's asking us to create an activity. In a nutshell, activity is a screen. It's going to represent a piece of UI that we're going to see in the application when it's all said and done. And also, if we do choose to have it, it's going to be a class. It's going to be a Java class. So as such, it needs to adhere to the Java naming conventions. So I'm going to name it hello world, right? Actually, let me change that to hello activity, right? So capital H, capital A. Finally, it's asking for the minimum SDK version. In the past, this number would automatically get copied from here. So whatever we chose here as our target has the API number level 8, right? Would basically just get copied in here. Everyone understands what API numbers are and all that stuff, right? Okay, so that's basically the capability of the framework. So in the past, this was the standard procedure. Now, the best practice is basically to really think about what is the minimum SDK that you require. So, for example, your application may be using some latest bells and whistles from the latest versions of Android, but you also want to be able to have users with older versions of Android use it as well, right? So you may, for example, say we're targeting Android 2.2, but we're going to work on as low as cupcake or donut, right? And what that means is that maybe your application uses some features, but it can gracefully scale down those features in case it's running on an older platform, right? You're going to have to do this programmatically, but at least you have the information available to you at the runtime. So, for example, Bluetooth wasn't available in the API until 2x, right? So maybe my application takes advantage of Bluetooth, right? So what I can do is I can say, yes, I'm using this API, but if the user is running on an older version of Android, we're just going to gray out that feature. We're just going to make that feature not available. The app is still going to run. So that's what the point of the minimum SDK version number is. Everyone got that? Cool. So with that, we now created a little hello world, and what I'm going to do is I'm going to open it up here. I just want to really briefly talk about how these files come together and what everything is. So this is our hello world application here. remember how I said an application is essentially a combination of two things, your Dolby code and your resources. So this is sort of how that breaks down, right? So this is your Java, right? And these are your resources here. Right? So these are your resources. So together they make that APK file, right? That's your APK file or application package, right? And then in addition to that, we also have a file that's important, and that's the manifest file. The manifest file essentially says what the big picture about the whole application is. So what version it's using, what its name is, its various components, permissions that it's using, etc., etc. So that sort of information goes into the manifest file. So what I'm going to do is I'm going to open up a couple of these files just to kind of show you what they look like, and then we're going to see how they relate to each other. Let's open this one up, and let's open up the hello Java. So I'm going to start this way. So we're going to start with the manifest file. So what Eclipse does, it tries to provide hand-holding when it comes to dealing with any XML file in Android that it's aware of, right? So as long as you're working with Android-specific XML, Eclipse provides this hand-holding in a form of forms, right? So it tries to help you manage the file by providing a view like this. And you can flip through multiple tabs at the bottom of this file. So this is my manifest file. This is my the components inside of my manifest file. Remember, that's our activities right there. These are various permissions, if we had any. Instrumentation. This is for automated testing, if we had any. But ultimately, you can press the last tab in the picture, and you get the actual raw XML. So this is what that file looks like. Now, don't worry about the details of this file too much at this point at all. Roughly, what it's saying is that we have a manifest file, and it's got an application inside of it, and that application has one component called an activity. Okay, so that's that main file that outlines the entire app. The next file that we have here is strings. Strings is basically one of the resource type files that is used for all your text. So essentially, all your English text should go into this file, right? And you can see that we have two pieces of text right now. There's a hello, so this is our hello piece of text, hello world, hello activity, and this is our app name, hello AnDevCon, right? You can also see that this is, again, just a raw XML file that looks like that. So it's basically just name value pairs. Nothing really too exciting about that. Now, as I said, the best practice is to separate text from separate resources from your Java. As a matter of fact, if your application is to be included into a custom ROM, into a build of Android platform, you must take all your text out of the applications and put them into resources, which we'll see later on. So the next file that we have here that I'm opening up is this file called main.xml, and it's basically a layout. What layouts are screens. They correspond to screens that you have in your application. This is the screen that corresponds to our activity, and it basically just says hello world, hello activity. And we have various widgets here. I can, for example, I'm going to downgrade this to 2.3 so that we have not the latest stuff, but close enough. So I can, for example, grab a widget from this palette. I can just drag and drop it, and there's a button now on my screen, and so on. So it makes it relatively easy to develop your UI, your user interface. Again, you can flip over to the XML view. I'm going to reformat it so you can actually see it on the screen. But that's basically what that looks like. So it's just a little bit of an XML. Yeah. So the question is about the minimum minimum SDK version. So they do not get that doesn't happen automatically. So you as a developer, you have the information, and you would have to check what the available version on the platform is and downgrade specific things. The only thing that gets checked is that if your application specifies in its manifest file that its minimum SDK required is, for example, 4, right, a donut, the application is not going to get installed on anything that is at least less than donut, right? So that's the only thing that gets checked. So it's at the install time. Right? Does that answer it? Okay. So back to this file. So this is the XML file that corresponds to the screen, the layout itself. And that file lives here in this directory layouts. Now the next file that we have is our file. And this is a file that people sometimes run into a lot of issues with, but let me just kind of explain it. So this file is first of all auto-generated, and you do not get to modify it. As a matter of fact, I don't like you to even have it open. You should not be looking at this file at all. The information in this file is not that important. It's basically a whole bunch of pointers, right? So we're not going to be looking at this file, but we're going to be using this file a lot, okay? The goal of this file, the purpose of this file is, so this file lives here. The goal of this file is to basically glue the world of Java, so this is the world of Java, right, to the world of resources. So essentially, R provides a pointer or a reference from Java, right, to resources, right? So these are our resources here. Make sense? So basically provides a hook from Java to XML.
What is that pointer to?
So the actual pointer, I'll show you that later on, but what happens is all your resources actually get quote-unquote compiled into a single file, right? And so this is a reference to a location in that single file. And I'll show you that in a second when we look at the actual binary side of things for this app. That's what that is. But again, the actual number is not important to us. Like I said, we're going to be using R, but we're not going to be referring. We're not going to be looking inside of R at all. Essentially, whenever you change anything in your resource folder, okay, R gets updated. So there's something watching R. Okay. So whenever there's a change, it gets automatically updated. Finally, let me show you the hello activity, the actual Java file, and that's the file here, right? So at the end of the day, it's all Java. Java is really driving everything, and the XML is just there to help us out. So this is how it works. Here's our class hello activity. As you can see, it extends activity. This is fairly typical in Android. You're not going to be writing a lot of Java code from scratch. You're going to be basically subclassing system classes, and you're going to be overriding specific methods. That's how we do a lot of coding. So it's not so much starting from scratch, but it's rather subclassing, inheriting from the framework, and making changes. In this case, what we are overriding is something called onCreate, and I'll explain what this callback is later on when we see the actual lifecycle of the activity. But as you can see, so we're overriding onCreate, we're calling it super, so far we're back at square one. We haven't done anything useful, right? So up to line 10, we haven't done anything useful. We just basically created the template to start doing something useful. So the first and the only line of useful code is this line 11. Right? So what this line basically does, it says set a content for this view. The view, for those of you, how many of you are familiar with AWT and Swing or Swing? Okay, so most of you. All right, so a view is what in Java we would call a component, right? So everything is a view. Anything that's kind of visual, with any widget sort of thing is a view. So we're saying set the content of this component to R layout main. So this is where we're using R. Let me explain this in a second. So what we're doing here, we're basically saying set the content for this activity to R layout main, right? So what we're doing is we're using that R file, which I said we're going to use a lot, but we're not going to look at. That's how we use it, right? And what that's doing, it's basically referring to resources, right? Layout main XML, right? So this is essentially a pointer to that file here. Okay? So what we're saying is set the content of this activity to that XML file. And what happens behind the scenes is this XML file gets read and it gets inflated into Java, and I'll talk about that in a second. But essentially, after this line 11, we have a whole bunch of new Java objects in our memory space that got magically created by processing that XML file. And we're going to talk about that because that's sort of where Android is unique with respect to Java and the UI. Does that make sense how this works? So the only thing that I wanted to show you behind the scenes is what happens with with this application. So I'm gonna look at the actual hello world here, and the only file that I haven't, the only folder we haven't seen is that's of interest is this folder bin, right? That's what the binary output is. And as you can see, this is where our APK got built. So it got built magically by Eclipse because we have, in Eclipse, we have, as you know, we have project build automatically checked on. So whenever you save a file, everything gets recompiled, right? That's why it's very, very important as you're developing to keep saving your files, right? And especially because files depend on each other, right? So if I make a changes in my strings file, that affects, right? Because it's in resources, that affects R, which affects Java. So you want to keep your files saved, otherwise things get out of sync, and that's where you run into compile problems. So back to this file. So this is our final product. That's our application. That's what we ship, right? This file here, APK file, right? And that file is really the sum of the resources and the Dalvik. Remember how we said APK file is you combine the Dalvik code and the resources, right? So all our resources are essentially quote-unquote compiled in this file here, resources.ap_, right? So all those images, layouts, graphics, sound clips, English, text, all that stuff gets combined together into this single file. That's what it is, right? All the Dalvik code is in this file. That's the .dex, it stands for Dalvik executable. It's kind of, this is comparable to a jar, right? Now, here's our Java. So all our Java files are right here, the compiled version. So basically, what happened magically is Java got compiled, right? This is the class files. Then that got recompiled into this file here, the classes.dex, right? Remember we were talking about how that happens? So although it's an extra step, you don't really care, other than it's interesting that that's what happens. But that's at the end of the day, we just have this Dalvik executable here, right? So far so good. All right. So now let's talk about running. Yeah, question. Yeah. So so first of all, Package Explorer hides bin folder from you. It's supposed to be a binary output, so as such is not interesting. So you got to look it up in the file system. So go to Places and then go. If you're using MyVM, I think there's already a link to your workspace. So yeah, but it's on the file system. It's just not in the. It doesn't get shown in the Package Explorer. Any other questions on this so far? Hello World, dissecting Hello World. So what we've talked about so far is creating a new project. Sort of what's important in this thing. Anatomy of an app. So what bits and pieces of an application are. We talked about the manifest file, the resource file, the Java file, and now we're going to talk about running it. Just a quick question. Does anybody not use Eclipse? Does anybody care about using a different environment? Notepad, VI, I don't really care, but something else? Yeah. NetBeans, I don't know a lot of people using NetBeans, honestly. It is one of the supported, IntelliJ and NetBeans are also supported, but it just happens that it seems like everyone's kind of standardizing on Eclipse that I know of, so yeah. You do not need Eclipse, you can run on a command line as well, yes? Emacs or something? Some people do. So let me just show you. So if I forget Eclipse for a second, if I wanted to run everything on a command line, and in that case, it doesn't matter if it's VI or whatever you use. So I'm gonna cd into my my workspace, and I'm gonna go to Hello World project, and so if I wanted to make this project, if I wanted to create a brand new project, I would do something like Android create project, right? And Android is one of the tools that's part of your tools directory in the SDK, right? Now, since I already have a project, as opposed to create project, I'm going to say Android update project. And I'm going to say -- path, the current working directory, right? And I can say -- name if I want hello world. So what this is doing is now analyzing the existing project, and it's saying, all right, what would it take for this project to be command lineable? In other words, not require fancy Eclipse tool. And essentially, the only thing that's really needed is the build XML for Ant, right? So at this point, I have a project that I can compile on a command line, so I can do Ant debug for debuggable version of the code, and that's now going to compile it on a command line. I can use VI, or I use TextMate, for example, so I can mate this directory. So in other words, you do not need a fancy Eclipse if you didn't want to use it. So this would be, for example, me working in TextMate as opposed to Eclipse altogether. Okay. But Eclipse, while it has some shortcomings, it's actually a pretty good tool for a lot of things Java and things Android. So we'll talk about that. Any other questions on this? All right, so let's talk about running this. So did you guys bring your phones? Yeah, okay. I'm just joking about that. You do not need it. It's good. I mean, if you have it, that's great. But we're going to be running it on the emulator. So let me actually create the emulator first, and then I'm going to explain what an emulator is. So there's a tool called Android, and you can start it from a command line by typing Android, like you saw earlier. Or anything you can do on a command line, you can usually do in Eclipse, and it's usually this button here, right? So I'm going to click on that, and that starts this tool. And I already have I'm going to delete this one. So typically you would not have an Android virtual device. So basically we can create these multiple virtual devices, right? We call them AVDs, Android virtual devices. So what I'm going to do is I'm going to create one really quickly, and I'm going to explain what is what. So I'm going to call mine gingerbread. You can call it whatever you want. Mickey, Tommy, anything's good. This is now the target of the device. This is what's installed on the device, the capabilities of the device. So I'm going to say this one is capable of, let's say, Android 2. Level 9, right? So this would be gingerbread. Next, what it's asking me is there an SD card in this device? And it's fairly typical to have an SD card, and I'm going to put a relatively small one, 20 megabyte card. Next, it's asking me for the skin of this device. So how big is the screen? What's the skin of it? And by the way, these skins are fairly simple to create. They're essentially image maps. You can create your own skin if you want your device to look like something totally different, like, for example, a car navigation dashboard, or a tablet or something like that. You can make them quite easily. So I'm going to choose the default WVGA800, or I can even do a custom resolution. And these are some hardware properties that you can specify. So for example, you can say my particular virtual device does or does not have accelerometer, battery, SD card, GPS, etc. So you can kind of configure some of the capabilities of the device. I'm not going to do anything special about it. I'm just going to click Create. What this now does is it creates a new AVD. AVD essentially is a virtual device that just explains some data about the device. Yeah, you have a question? The question is about the 20 meg SD card. So that is the size of the file system that I just allocated for the SD card. Let me show you. I'm going to start it. It takes some time to start. So I'm going to start it, and because of the resolution of the screen, I'm going to resize it to fit. But you guys don't usually have to do this. It fits on it should fit. The size is right. Yeah, size is perfect. Otherwise it gets chopped off. So while this is booting, a couple of things. I'll get back to that question. A couple of things. Do you guys get the difference between a simulator and an emulator? Sounds the same. It's fundamentally different. So a simulator simulates behavior of something, right? It basically behaves the same as the real thing, but it's not the real thing, right? Emulator, on the other hand, emulates the low-level hardware. So essentially what we're starting up is a virtual machine, right? So the code that I'm booting up right now is ARM-based binary code. So everything that I'm booting up right now is 100% identical to a physical device. So it's the same binary code down to ones and zeros, right? The only exception is certain drivers, such as radio, for example, and things like that, right? Because obviously there's some limitations running in a VM. So certain things we can fake, such as GPS, but certain things we just can't fake, such as sensors, right? I tried shaking my laptop, it didn't work. So so just so you know, so that's an important thing to understand, yeah. Can you set the CPU speed, the network bandwidth? Yes, you can do all that stuff, but I would do that as part of the platform. So in other words, you can build a custom Android, and then you can do all these sorts of things. There's init.rc file that specifies a lot of these settings, but that's a different conversation. That's about building a custom ROM, and when you do that, you're God. You can do whatever you want, right? But on the actual emulator, out of the box, as an app developer, things that you can control about this emulator are available to you via this perspective called DDMS. So you guys should have the DDMS perspective. If you don't, go under Window, Show Perspectives, go under Other, or find it. But you should have a DDMS perspective. So let me just pop it up here. So DDMS perspective stands for Dalvik Debug Monitoring Services, and it basically is sort of the perspective that you use when you run code. So Java perspective is what I use when I write code, DDMS when I run it. And as you can see, I have my emulator here. It's registered under devices, and I can also control certain things about the emulator. So there's certain controls, such as I can specify the telephony speeds, right? I can say that we only have GPRS or GSM for speed, and the latency is set to edge, and that we are roaming, and etc., right? I can even make phone calls to my device, right? So I can say, let's pretend we're making a call to our device, and you're going to see that there's going to be an incoming phone call from 555-1212. Is it? Oh well. Let me say send an SMS. Testing. Send. No, you just need to specify a number. So this is one of the examples where Eclipse may or may not work perfectly. But there's always a plan B, and the plan B is always to drop down to a command line. So let me show you what you can do on a command line. You can basically telnet to your device, to your emulator. You can do a telnet, localhost, and then the port that you want to hit is the port that says here, right? So in this case, it's 5554. So I'm going to telnet 5554, and you say help, and it tells you, various things here. So for example, I can say help GSM. Okay, so I can make a call, right? So help GSM call, right? And it says phone number. So I should be able to do GSM call 555-1212, and it says OK. So I'm not sure why it's not connecting, but that's how you would control the emulator from a command line, right? Which is useful because you can do a lot of automation that way. So I'm going to close that. Back to your question about the SD card. So when you guys create an emulator, behind the scenes what happens is there's a directory in your off of your home, right? So that's called .android. So on Linux, Unix systems it's going to be hidden, but it's called .android, and this is true also for Windows users, right? So it's going to be in your documents and settings, whatever the path is in Windows. Look for a directory called .android. And in this directory, there's going to be a subdirectory called AVD, and that's where your virtual device is. So cd AVD, and that's where our device is, right? So I'm gonna show you really quickly that if I cat gingerbread INI file, it's basically just saying, you know, what it's based on. So it's based on Android 9, i.e. 2.3. And it says that the actual data is in this directory. So I'm going to cd into gingerbread avd ls, and this is where the file system images for this device are. So in other words, the SD card is right here. This is that 20 meg file. That's the equivalent of the little, you know, plastic thing that you stick into the physical device, right? This is the user image, which corresponds to everything that user is changing. So that's where, when you download the apps, that's where it goes. When you add Bobby to your contact list, that's where the data is saved. So that's basically the user-specific data, yeah.
I'm sure I'm probably doing it wrong, but my experience has been that I don't get an SD card unless I actually specify a file. And then when I bring the thing up, the emulator up, it just says no SD card installed.
Yeah. So back to the SD card. So when you're creating the AVD, you're asked about the SD card. So you actually got to give it either a size for it to be created, otherwise it's going to be non-existent. Or you can point to an existing SD card, which you can create using a tool called MK SD card, which is also part of your SDK tools directory. Yeah. So you can create it and add it into the thing. So yeah. But this is these are the basic. This is behind the scenes what goes on with the emulator, and those specifications that we specified about the capabilities of the Android of the AVD are here. So this is what's basically saying, you know, a little bit about the this. So with that, what I'm going to do is I'm going to run our application. So now that we have it running, so I'm going to go back to Java. And I'm going to click on Run Android application, and I'm going to basically, what we're doing is we're installing that APK file onto the device and launching it at the same time. So so there's our application. It's hard to see, but it says hello world and all that stuff. There's a little button that does nothing, but you know, nonetheless, we got it installed. Now just back to, you know, everything you can do Eclipse, you can do command line as well. So if you're doing this on a command line, remember we built it successfully on a command line, right? So we built it, we ran end to build it. And if I go to my bin folder, there's my APK. As a matter of fact, I have a couple of them, but let's say it's a hello world.apk. So how would I on a command line push this from the laptop onto the device? Keep in mind that this virtual device is for all purposes equivalent to having a physical phone connected to the USB cable, right? So it's a totally separate machine. It's a totally separate computer. So how do we bridge from my Mac to my Gingerbread AVD? And the tool for that is a tool called ADB, Android Device Bridge. Okay, it's a very important tool, and you end up using it on a command line a lot because it's very powerful. So just, you know, you want to get familiar with it. But basically, what I can do is I can say ADB install, right, hello world.apk. And what this is now going to do is it's going to push this APK across the wire, although in this case the wire is virtual, right, onto the device. And in this case it's going to fail because I already have it installed. So what you can do is you can say install -r, and now it's going to reinstall the application onto the device. Does that make sense to everyone? What happens? So I know we only looked at the hello world, but we kind of like are looking a little bit more sort of inside what happens behind the scenes of all this stuff, right? Any questions or comments on that? Yeah. Are there any tools in Android to help you scale between different screen resolutions of what? Of the actual device? Yeah, so when you're creating the device, you get to say what the density of the screen is, right? So back to the screen. So if I was creating a new device, I get to say first of all, let me pick a target, for example. I get to specify the resolution here. or a skin. I could, for example, say, look, 1024 by 768. Okay, so this is the resolution. Now I also get to specify the density of the screen. Right? Most of the new displays are 240 dpi, and most of the old, which is known as the high HDPI, high density per inch, as opposed to medium density per inch, which is the 160 dpi, right? So you can configure it here. Yeah. Yes. So when you're starting a device, you can say start, but you can scale it down. So, but this is just literally just shrinking it, zooming it down. So I do this because on the projector, my resolution is just slightly smaller in the bottom where it gets chopped off. So essentially, I just scaled it by a factor of 85. But that's it. It's no big deal. Just scales it by 85%. Yeah. So what's the strategy if you want to target many devices? And actually, I think Mark Murphy is giving a talk right now, next or tomorrow, on specifically this, on how to deal with the fragmentation and all that. But basically, you want to be able to when you say your target, right? You may shoot for the latest greatest device, but when it comes to the minimum SDK required, you want to be able to specify as old a device as possible, and then gracefully scale down your feature set, right? What we were talking about earlier. So, for example, I may want to take advantage of near field communication in my app, right? So I'm going to target, Gingerbread, right? But near field communication is barely available on only one device, right? So not many people have it. So if I want to check if the device actually has that, and if it doesn't, I want to disable that particular feature. Right. So far so good. All right, so moving on from this, let's talk about the main building blocks. We're going to basically start with this. And this is a section that's, in my mind, very important, as I said, because it's very specific to Android. So there are aspects of it that are, you haven't seen anywhere else, more or less. Everything else is Java, but this is something that's new. And before we start, I'm gonna run a little application that I have. Hopefully it's gonna work. I'm not sure about this internet proxy that we have. But the application is basically, it's called Yamba. It's yet another microblogging app, i.e. it's a Twitter app. So let me just execute it here. So I'm installing it on a brand new device. So it says please enter username and password because it's the first time we are starting this application, so we don't have username and password. So I'm going to click on username. The username is student. Oh. Have you ever noticed that when you start typing and it's all characters you don't know? So the reason for that is that for some reason the default on a device is to enable I believe it's a Japanese keyboard. So what you want to do is you want to go into language and keyboard, and you want to turn off anything you can't pronounce. So okay, so let's try this again. So username. Of course, I could have specified. This is much better. I could have specified which specific keyboard to use in this case, but I didn't. So username is student. Password is, I believe, password. Okay. Server. So let me just explain this. We're not using Twitter per se because Twitter. There are multiple reasons for that. For one, it banned us. Because too many people at the same time with the same username and password, you get how it gets denial of service tag kind of considerations and disables it. But also, so that's one of the reasons. So we have our own server that's using the same API. So it's the same Twitter API. It just hosted on a different place. So it's yamba maracana.com/API. So with that, I should now be able to go to to my application, and it doesn't have anything, so there's no data right now. What I'm gonna go is I'm gonna go and I'm gonna say update our status. And by the way, so this is connecting to a server that looks like this. So Yamba Maracana.com, and so this is what it's on it right now. Okay. All right, so we'll have to deal with that. But so if I say hello from San Mateo, click on update, this is now going to be trying to connect to, okay, so it failed, but at least it told us that it's failing. So it could have failed for many different reasons, but network connection is probably the yeah. That's fine. Well, we're gonna work around that, but yeah, that's basically what it does. So my point about this is, here's a medium-size app. It's got a couple of screens. So this is a screen where you send your update. There's a screen where you can see what your friends are doing. There's not a lot of data here right now because we can't connect. There's a screen where you can update your preferences, right? So that's what the app looks like. There's also a service behind the scenes that is updating the data, etc., etc. So with that in mind, right, with this as a sort of a motivation for the following conversation, let's start by talking about activities really briefly. So activities is one of the main components that you use to build an app. It's the UI, right? So roughly one activity is one screen, right? Your application may have multiple activities. Just like a website has multiple web pages. They make, multiple web pages make a website. So you usually have an entry point. So you usually have the home page, the main activity, right? The activity that gets started when you start your application. Now, what's interesting about activities is that activities have a fairly involved life cycle. So the life cycle of an activity is fairly managed. And this is where I find programming for Android may be different than what you guys are used to in programming in standard Java. So in Android, we're sort of programming in a container environment, right? Sort of like if you have experience with applets or servlets, that's what I'm talking about. So you're basically writing code that is responding to the callbacks from the container, right? Just like servlet or an applet environment. You're responding to init, start, stop, and so on. So here, what we have is we basically have a activity at the beginning of the day does not exist. So we're in this starting state. And the user goes and clicks on the app, says, I want to start the application, and the initial activity of that application gets started. So through the startup process, the following callback methods get called: on create, on start, on resume. Right? And ultimately, we get into this running state or visible state. This is when your activity is visible on the screen. You can only have one activity ever visible on the screen. Right? Now, the goal of the system is to make user experience as zippy as possible. So this is the activity that gets all the preference in the world. It gets all the memory, all the resources, everything. So basically, so that's what happens with the running activity, the one that's in focus. Now, the user may jump from one screen to the next, and what happens in that case is the activity gets paused really quickly and then stopped. Okay, so pause state is sort of not very common to stay in. Pause basically means that your activity is partially visible but not in focus. Right? So on a typical small device, you don't have this happening a lot. That would be equivalent of like having sort of a dialog box or something in front of your screen. So your screen is still visible, right? But it's not, nobody can touch it, right? It's not in focus. So it doesn't happen that often, but we always run through pause state en route to being stopped. Now, stopped activity is very common. So we have many, many activities in this state hanging out, just being stopped. At some point, system may simply decide to kill the activity, right? So you, as a developer, do not have a say in this, right? As a matter of fact, you as a developer don't have a say in what state your activity is in. The only thing you have a say in is what happens on the transitions from a state to a state. So we control these, right? That's what we control. But we do not control the state that it's in, right? So we're in a container environment. So at some point, system may decide this activity no longer needed, wants to free up memory, kills it, destroys it, right? Or a user may say, oh, I want to get back to that screen. Right, the screen that I was just on, I want to flip back to that screen. You press a back button or some other way navigate back to it. Maybe it's some activity that you used a couple of minutes ago. It's still in memory, right? So in that case, this is what happens. We bring it back into the running state. Yeah, question?
What about on the on-save instance?
On-save instance state. So those methods are also here. I didn't. So basically, what happens is there's one additional method here called on-save instance state, and there's an additional method right here called on restart when you're restarting, loading the instance state.
The reason I'm asking you.
Yeah. So the question is, what happens if you're like in the middle of typing something and the phone call comes in and now your activity, for example, goes from running to stopped, but you don't want to have the user start typing from scratch. You want to kind of save that information, right? Or another good example in the past was just rotating a screen.
Yes.
Maybe I'm typing like my long tweet and accidentally rotate the screen. And what happens, we actually do this whole thing, you know, sort of again, we restart it. So we go here and then we restart it over again. So when with the rotation of a screen, the entire life cycle actually recycles the app. By default, you can control that behavior. So, so what happens is there's a way to save and restore the state. So you get something called a bundle. A bundle is basically a data structure that's name value pairs, and you get to leave information for yourself for the next reincarnation, if you want. So that's what on save and on restore are. Now that used to be a much bigger deal around Cupcake release. But later on, they actually improved the frameworks. So a lot of widgets are actually smart enough to do that themselves. So in other words, a piece of text is going to, let me show you, a piece of text, if I'm typing something here, let me go back to the screen, and I'm typing hello
There
from...
seems to be no guarantee which do save themselves and which don't.
So yes, so control F11 is going to rotate it. And there, it saves itself. And this is just a standard UI widget called edit text. So I didn't do anything special to preserve that piece of text. Yes?
Can you go back to the other screen? So from the stop stage, there are three methods. I'm kind of surprised on the film that was unresume from stop, on restart.
These three?
Yeah.
Yeah. So, back to the previous question, there are more lifecycle methods. I kind of pulled, you know, I'm trying to keep this like as little confusing as possible, so I only pulled the more important ones in here, trying to keep it sort of for educational purposes simpler. So that's why I only kind of focused on the main methods. But there are more methods for sure. So why do we have three here as opposed to just one? Let me get back to that question in a second. I just want to kind of explain why do we have so many states in the first place, right? Because, for example, iPhone just does this. You start, you go into running, you're running, and then you go and you get destroyed. So why not keep things simple? Why didn't we do the same thing? So the reason for that is that this part here is quite involved. There's a lot, when you're starting an application, and starting an activity, a lot of things happen. You need to create a brand new Linux process for it. You need to load the virtual machine into it, because in Android we have sort of a sandbox, and each application runs in its own process with its own Dalvik VM. It's totally isolated from anything else for security reasons and such. So we need to start all this, allocate memory, all that stuff. We then need to parse our entire XML layout, and we need to inflate it into Java. So a lot of Java object creation, which, as you guys know, it's one of the most expensive things you can do in Java. then we need to draw that on the screen. In other words, these steps here are quite pricey, right, in terms of the memory and the CPU cycles. Now, user is now in this state. User is likely gonna, leave that screen, but just as likely is that the user is gonna come back to that screen at some point. So that's why stop state is sort of a cached version of the application. So that if you want to come back to it, this is much cheaper comparatively than starting it from scratch. So first of all, that's the reason why we have such a relatively complex life cycle here. Okay? Yes? I'm talking about an activity. And that's a very a lot of people confuse those two things. Right. So assuming that you're just starting an application. So typically, if you're starting an activity, I just powered up my phone. I'm starting that cool new app. That actually, if the application doesn't exist, the application is good to get started as well. But you're right. For subsequent activities within the same application, you wouldn't need to start the application. Yeah. So now, why do we have? So that's why the life cycle is the way it is. Now, why do we have so many different methods? Well, because you may want to do certain things in certain places. So let me give you an example. So unlike developing for web or developing for desktop, one of the things that we care about in Android a lot is battery, right? That's one of our main concerns, right? Like when I was programming for the web, I was concerned about concurrency and fault tolerance and all these crazy things, right? We don't care about that here. We care much more about the battery. So, for example, using things like GPS is fairly expensive, right? GPS just sucks the battery dry very quickly. So, if I have an app that uses GPS, when do I want to start listening to GPS and when do I want to stop listening to GPS, right? So I have all these different placeholders where I could do that. For instance, I could say I want to start it here, right, in onCreate. But that means that I'm going to be listening to GPS for an undetermined amount of time because I do not control when it's going to get destroyed. When am I going to stop it, right? So let's assume that I'm smart about this and I want to listen to GPS only in this state. In other words, while we're visible. In other words, when we actually have the actual use for the information. That's how it's typically done. So what I would do in that case is I would say, all right, let's register for listening to GPS on resume, okay? And because all the roads into running lead through, not this one, but all the roads to running lead through on resume, okay? There's on resume, right? And there's on resume, okay? And let's unregister in on pause because all the roads out of running lead through on pause, right? So that's how I would accomplish that thing. So that's why you have multiple methods here, back to your question, right? So for example, I may say, no, I want to actually listen to the thing while in these states, even when I'm in the background. So in that case, I may say, okay, let's do it in on start and let's undo it in on stop, right? You may say, I want to do it on restart, right? Which only happens here, right? And so on. So you basically have these different placeholders so you can accomplish what you're doing, what you're trying to do. Does that answer that in terms of the life cycle? Okay. So this is a very important thing from I find coming back to this picture many times. It's kind of like layers, peeling an onion, right? There's many layers of understanding how the life cycle works and how you should be using it. But just back to the code in our little hello world. Basically, what we're saying here is we're saying we're going to subclass activity, that's our hello activity, and we're going to override on create. So that's our entry point. In this line here, that is that expensive work that we do of loading up the XML, parsing it, and drawing it on the screen, right? So in this particular activity, we do not do anything else. So on create is something that you almost universally override when you work on any particular activity, right? It's sort of like your init method or constructor. Yeah.
So,
Yeah. So the fact that I don't override the other methods, they're simply there by the fact that we're extending activity, right? So I'm just not overriding them. But they are there and they do something useful. So that's why whenever you override one of these on methods, you have to call the super of it and basically do whatever the parent was going to do anyhow, because it's not just a blank method, right? Yeah. Yeah, is it possible for an activity to start another activity and pass name value pairs? Yes, it is, but not through a bundle. So basically, an activity starts another activity via intents, which is our next conversation. And an intent is sort of like a URL with a get. You know, you can put $ID equals 47. So yes, you can pass some primitive data types, and we call them extras in that case, but it's just a name value pairs. So yes, it is possible for that purpose.
So who would ever?
So the system may pass the data. Typically, first time around, when you just start an activity, this is going to be null.
Right.
Okay. But if an activity is going through just a quick configuration change, such as the screen rotated. So when you rotate the screen, by default, the activity is going through the whole reincarnation, of itself, right? And in that case, the system is going to preserve some of the data in saving in that bundle and pass. Yeah. So we're at 10 o'clock, so we're going to do a break now. But before we do a break, I just want to quickly check in with you. Is this new stuff for you guys? Old stuff? Is it going fast, slow, about right? Good. Okay. All right. Okay. Let me know so we can adjust. Cool. So I'll see you in 15 minutes. Okay.